Hello everyone, I am Dr. Rajesh and I am again with you with my next video lecture. And in this video lecture we will study effect of error in tabular value. That is how the error in the tabular value in any of the value, that error how contributes it to the forward difference table. So that we'll see. For an example, if we see y1, y1, y2, y3, y4, y5, y6, y7, y8, y9, and y10, we are taking 10 values, are the values of the function at say x0, x1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Fine. So these are the values of y at x, and this is y is equal to f of x. Fine. So these are the true values of y, which is equal to f of x. So if let us suppose that there is an error in any of the value, and let us take the error is in this value y6, say this error is y6 plus small error is given, then how the presence where e is error in the value y6. So how the presence of this error does affect the forward difference table, and how the presence of this error propagates into the different columns of the forward difference table, that we will see in this article, that how a single presence of single error in any of the value, any of the true value, how that error is going to affect the other columns of the forward difference table. So for that we will form the forward difference table. So this is the table, and in this table for values of x 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we have corresponding values of y as y1, y2, y3, y4, y5, y6, y7, y8, y9 and y10, and these are true values. And for the sake of simplicity, we assume that there is an error in the true value, and that error is given by, say, that error is given by y6 plus e, where e is the error in the true value y6. So now we will see that how this error will propagate in the table. Now we will form the table y2 minus y1. Here you will write y2 minus y1, that you know is delta y1. So here you will write delta y1. Here y3 minus y2, that you will write delta y2. y4 minus y3, y4 minus y3 is delta y3. y5 minus y4, delta y4. And y6 plus e minus y5, this y6 minus y5 is nothing but delta y5 plus, so here will be delta y5 plus e. Okay. Similarly, y7 minus y6 will be delta, and here will be minus, it will be delta y6, and it will be, look over here, y7 minus y6 minus e, this will be delta y6 minus e. So here will be minus e. Similarly, y8 minus y7 will be delta y7. It will be y9 minus y8 is delta y8. y10 minus y9 is delta y9. Fine. So error at one place has propagated to two places in first order column, first order forward difference column. It has propagated. Now we'll move further and see what happens next. Delta y2 minus delta y1 is nothing but delta square y1. So this will be delta square y1. Delta y3 minus delta y2 is nothing but delta square y2. Similarly, it will be delta square y3. Now look over here. This will be delta y5 plus e minus delta y4. This will be delta square y4. So this will be delta square y4 minus, it will be plus, e. Fine. Similarly, this will be, I am doing it over here, delta y6 minus e minus this quantity minus delta, this is e, delta y5 minus e. So this and this is nothing but delta square y5. So I am going to write delta square y5, and minus e is minus 2e. Fine. So this will be, next will be delta y7 minus, and it will be plus. Now delta square y6, it will be delta square y6, and it will become plus e. Fine. Similarly, it will be delta square y7, and it will be delta square y8. Now you see over here that it has, in the value of y, error was only in two terms. Now it is in first column, it is in two terms. In second column, it is in three terms. Now we'll see how we'll propagate in the third difference column. So we'll see, and we'll write delta square y2 minus delta square y1 is nothing, delta cube y1, and you have to write in between here, delta square y3 minus delta square y1 is nothing but delta cube y2. Fine. and this will be delta square y4 plus e minus delta square y3. This will be plus e will remain same. This will be delta cube y3 and it will be plus e. So for e I am going to use this color. Fine. Now similarly difference minus 2e, it will be minus 3e. So this will be delta cube y4 delta cube y4 minus 3e, and this will be plus 3e. Delta square y6 minus delta square y5 is delta cube y5 delta cube y5, and it will be plus 3e. Fine. And this will be delta square y7 minus delta square y6 is nothing delta cube y6, and it will be minus e. Fine. And it will be delta cube y7. Now can you see over here, error in the third order forward difference column is there, and that is there in 4 terms. In second order column it was in 3 terms. In first order it was in 2 terms. So it is propagating. So now let us see what will be the case in fourth order forward difference column. So this will be delta 4 y1, and this will be delta cube y3 minus this will be delta 4 y2 plus e, and this will be delta 4 y cube and it will become minus 4e. So this will be delta 4 y3 minus 4e, and this will become delta 4 y4 and it will become plus 6. Fine. Plus 6e, and it will be delta 4 y5 and it will become minus 4e, and for this I will be writing in this color 4e, and this will become plus e. So this will be delta 4 y6 and it will become plus e, and for e I am using once again this is plus e. Now see, there is error now in fourth column, fourth order difference. There is error in 5 terms, and here was error in 4 terms, here was error in 3 terms, here was error in 2 terms. So error is propagating with every next column. So how it is propagating? It is propagating in triangular form, like it started from here and it is going in this direction. Fine, agree. So if I say this is going in this direction, so it also started from here and it is going in that direction. So if I say that it is propagating in triangular form, So now from here we will make some observations. So the observations that we will make are, now see the observation, the sum of the errors in every column, whether it is odd difference column or even difference columns, the sum of the errors is always 0. Like here is plus e, plus 6e is plus 7e plus 8e and minus 80. So sum of error is 0. Here is also minus 3 plus 3 e minus e. So this is also 0. And here is 0 and here is 0. So in every column, sum of errors is always 0. Sum of errors is always 0. In every column. Fine. Sum of error is 0. This is observation number 1. Now next observation that you will see, the error value, the value in which the error is present before the value that is highest error value, numerically highest value. Now second observation is that for even column we draw a horizontal line, and that horizontal line like will start from the term that is having the highest numerical value, and this is containing plus 6e, so this is having the highest numerical value. So when we will draw the horizontal line from here, this will go something like, and this horizontal line will meet the value in the given table where error was present. So if we are asked to find the error present, then we will, if we try to estimate it with the help of the even order difference column, then we will plot a horizontal line from the largest numerical value present in that column, and the value of y present on that horizontal line will be the value containing the error. So that is the observation number 2. Now next observation is that, if we try to estimate the value in which error is present with the help of odd difference table or odd difference column, so in that case, like minus 3 plus 3 both are numerically equal, so in between them we will plot the line, like horizontal line in between the numerically largest values, and we will see that the value having error is present in that horizontal line. So for odd difference column, we plot the line in between the two numerically largest values, while in case of even difference order column, we plot a horizontal line against the largest numerical value. So this is the difference between odd and even difference columns used to estimate error value in the given table. Fine. And for that you will make sure that the value against which you are drawing the line, you will make sure that in that particular column either sum of the values is 0 or it is minimum with respect to its succeeding and preceding columns. So that sum has to be, I am writing sum of the terms of the column has to be either 0 or minimum with respect to succeeding and preceding columns. Fine. So that sum has to be either 0 or minimum with respect to preceding and succeeding columns. So what does that 0 value will imply? That will imply that of course some of the errors will become 0, but the 0 in that value also implies that the preceding these values were constant. Preceding these values like delta q by 1, delta q by 2, these all were constant. So that is why these have become 0, and of course their sum is also 0. So that is why when in any of the column the sum becomes 0, that implies that the error sum is of course always 0. But if the sum, overall sum is becoming 0 including the error, so that means that these terms have also become 0, and that is only possible when these terms are the preceding column, the terms in the preceding column have become constant. So that this concept we will be using in the problem solving. When the sum will become 0, that will imply that the terms, which term? Forward difference terms in the preceding column will become constant. So that is why the whole sum will become 0. So that is the another observation, and we see that these errors are nothing but the coefficients of the binomial theorem. Like if we apply the binomial theorem for this, if we apply binomial theorem for 1 minus p raised to the power 4, and in this case if we apply for 1 minus p raised to the power cube, so it will be, now you will see if we do the expansion, it will be coefficients. I am only writing coefficient. First will be this one, another will be this one, next will be alternating position, and the last will be, fine, this will be 1 minus 3, this will be 3 and minus 1. So these are the coefficient, like E coefficient is 1, E coefficient is minus 3, E coefficient is 3, and E coefficient is minus 1. So if I write over here E, so this will become E minus 3, 3 and minus E. Similarly, if we write the coefficient for even column, even difference column, so what it will be? So let us write the coefficient C40, C41, C42 minus 4 C3, it will be C4C. 1 minus 4, this is 6, this is minus 4, this is 1. Now look over here, E coefficient is 1, this is minus 4, this is 6, this is minus 4, this is 1. So the binomial, the errors present in the columns are binomial coefficients of the expansion, like 1 minus p raised to the power order of that column. Like for fourth order, this is 4. For third order, this is 3. Fine. So that is how we estimate and find the errors. So these are the binomial coefficients, errors present in the different columns, that is even difference and odd difference column are binomial coefficients. So that is the next observation. So these are the various observations that we have drawn, and we will make use of these observations while we will be solving the numerical problems. And in this article we have shown that the error is propagating in the triangular form. Earlier it was present in one entry. In the first order column it is present in 2 entries. In second order column it is present in 3. In third it is 4. In fourth it is 5. So it is propagating in the triangular form, and so it will be present in each and every column unless the difference column becomes 0. Okay. And secondly, we also observed that how we will locate if we are asked to find the value in the given table that has error. So we will be checking the sum in the column, and whichever column makes the sum as 0 or minimum with respect to preceding and succeeding column, we will take that column. Like if this column makes the sum minimum, so since this is odd difference column, so this will be having two numerically largest values. So in between them we will draw the horizontal line, and the value of y laying on that horizontal line will be the value containing the error. And if the even difference column will make the sum 0 or minimum with respect to preceding and succeeding columns, so in that case we will select the largest numerical value and will draw the horizontal line against that, and the value of y present on that horizontal line will be the value having the error. So that is how we will locate the value in the given table that is having error. So I hope that I will be able to illustrate the concept with you, and you will be able to grasp the idea. And in the next video lectures I will be taking 1 or 2 numerical problems based upon this concept. So this will make this concept more clear in your minds. So with that I just sum up this lecture, and very soon I will be with you with my next video lecture, and in that video lecture we will take the numerical problems. Till then, take care, bye bye, see you soon. This is Dr. Rajesh saying goodbye, take care, bye bye, and see you soon.